Hello everybody, get ready to start lesson 3.3 of Algebra 2 Math. And part 3 would be available here. Going to get ready to do 3.3 part 2 here for Algebra 2. 3.3 part 2, perform function operations and compositions. We have 5 points here today of notebooks taking, and got 24 points here of classwork skills sheet today. In our classwork page 1 on our classwork sheet today. Solve a multi-step problem for a white rhino. The heart rate in beats per minute and lifespan S in minutes are related to body mass in kilograms by these functions here. So R of M equals 241, this number here, and S of M equals this here. So we have two functions here in beats per minute and lifespan S here for body mass, where they're related to lifespan here in minutes, by the way. So R would be heart rate affects your lifespan, as well as over here body mass would affect your lifespan. So we're going to find the functions here when they're multiplied together. The beats per minute lifespan and times the body mass function for lifespan. Find and simplify our R of M times S of M. So here it is, here 241, and we're just going to multiply these two together here. Just write products of R of M and S of M together. So page 2, here's when we multiply together our two different functions, and then we have M here, and we're going to, this is a product of powers property here, and then this is the 241 that was in, I think it's the R of M, then 6 times 10 to the 6, and then M to this power here. And so when we continue our multiplication here, we multiply through times this, times 10 to the 6, 241 times 6 times 10 to the 6. And then when we combine these two, we get M to the negative 0.05 power. And then we can use scientific notation down here. We move our decimal place over, let's see, 1, 2, 3. So we add 3 positions to our decimal place up here. So it's 1.446 times 10 to the 9th. Multiplied by M to the negative 0.05, and that comes out to the amount of when you multiply R of M times S of M, we're multiplying heart rate by lifespan. Multiplying heart rate by lifespan gives total number of heartbeats for a white rhino over its entire lifetime. So this would be the heartbeats over the entire lifetime of a rhino. Now, using the results of example 3 to find a white rhino's number of heartbeats over its lifetime, if its body mass is 1.7 times 10 to the 5th, then down here you have something of a similar situation here, students. So work on that. Let's going to do our guided practice now. So getting back to the rhino thing, if its body, we have a different body mass here, 1.7 times 10 to the 5th. So R of M times S of M, we have 241 M to the negative 0.25, 6 times 10 to the 6. This was the one that we just did down here, and we ended up with this as our number of heartbeats over its life. Now we're going to change it. We have this body mass here now, so when you multiply this together here, 1.7 times 10 to the 5th to the negative 0.05 power here. This is how it looks on a calculator when you enter this in. So we have 1.446 times 10 to the 9th multiplied by 0.55 here. Negative 0.05 up here. Again, we multiply this through 0.55, we get this number here, 795.3. So we get 789,855, or 789,855,335 heartbeats for a rhino that has that body mass that we used here. This body mass here times the amount of heartbeats. Okay, moving on here. Composition of functions, another operation that can be performed with two. Okay, page 5 here on our classwork. A concept slide here, composition of functions, what we're going to talk about. And here is a diagram for a composition of function g with a function f is h of x would equal to g of f of x. So input of f would be produce the output of f, which would be the input of g, which becomes the g of f of x. So the output of g would be created by the output of f in this case. So anyway, g of f of x, you would first run f of x, and then the output of that you would stick in g, is what that means there. So the domain of g is created by the range of f, and then the range of g is created by ultimately the input of f. Kind of confusing. Well, the domain of h is a set of all x values such that x is in the domain of f and f of x is in the domain of g. So it's a way of creating the domain of g is the output of f. Okay, composition here, students, in your own words, define composition of functions. That goes in your notebook. And then page 7 of our classwork today, example 4, do we have a standardized test format here? Let f of x equal this and g of x equals that. What is the value of g of f of 3? So to evaluate g of f of 3, you must first find f of 3. So we stick 3 in here for f and we get negative 1. Now we can stick that into g. So g of f of 3 equals g of negative 1. And we stick that in g and then we get 5. So that's an example there of a composition of functions. So the value of g of f of 3 is 5. The correct answer in that case would be D. And that's also important for your SAT practice as well. Okay, got a practice here, g of f of 5. Let's find that. Students, this is yours down here, f of g of 5. Students, so pay attention so you can do your independent. Okay, into our guided practice here. This is f of x, this is g of x. So we're going to find g of f of 5. So how do we do that? We stick 5 into f of 5 here, up here, and we get 7. Now what do we do with 7? We stick 7 into our g. So this is our g, 2 times 7 squared. That's where that 7 comes from there. We stick our output of f into g, and then we get 98. So that's how that's done. And that was 3.3 part 2. Part 3 is available here as well as quizzes and everything else. Thank you very much.